All right. Good afternoon, everyone. Can you hear me all right online? Awesome. Okay, so today, my goal for today's class is to introduce the final project, which all of you need to complete and talk about that in a very slow pace because there is going to be a lot of things going on, and I do want to make sure that you all understand what the project entails and how it's going to go. So I just pushed to GitHub this folder 07 final project. So if you download the latest version, there is a QMD for project instructions. I'm going to launch that on my side and then we're going to get started. All right. So as you download this data from GitHub, you're going to see that there are going to be there's going to be one file, the project instructions.qmd, which is the one that we're looking into. And there's going to be two folders, one saying 50 acre, the other saying beach. These are the names of two different fields that you're going to be working with. However, really making sure that you understand this, you have been assigned one of these fields, so you're not doing both. You're just doing one of them, and you do not get to choose which one you do. You do whichever one was assigned to you. So as you check the project instructions on RStudio, when you launch that on RStudio, you're going to see that the first thing I have here is field assignment. So Benedetta, Polly, Kiathi, and Luke are going to do the 50 acre field, which is one of those folders. And then Amandeep, Marco, and Mohit are going to do the beach field, which is the other folder. Just to make sure that you all understand, you only do one field. You do not have to do both fields for this final project. All right, so the whole goal of this final project is that we're basically pretending that you open a business, a consulting business, and you'll be implementing a lot of the skills that you'll learn in this class as part of your business. Your first client is Mr. McCormick. Mr. McCormick is a real person. So the data that I'm sharing with you is all belong to his farm, and he has some questions for you, and if you can help him, given the data he's providing you, if you can help him answer some questions as well. So he really wants to experiment with precision ag, but he has seen his neighbors use out-of-the-box precision ag services that don't seem to work reliably. And you are coming to the table, opening your consulting business with precision ag tools that are really based on science. We're checking a lot of things. We're making sure that what we're doing is very objective and that there's little room for subjectivity here. So he heard about your science-based precision ag approach and is very interested in trying out your services on his irrigated fields. So he has two irrigated fields we're going to be working with. Of course, again, each of you only work with one field. Mr. McCormick also graduated from UGA, and so he is a very well-educated farmer. He has a lot of skills about precision ag and data analysis, making him a very curious farmer to work with. So he really wants to know everything that you're doing, all of the decisions you're making. He wants to be part of that process and understand your decision making. One of his questions to you is whether or not his field has different zones related to yield potential, and if he should use variable rate fertilizer application to reduce costs and improve efficiencies in his operation. What he's providing you to begin with are the following sets of data. So he's providing you with the field boundary. He's providing you with gridded soil data that was in fact collected this year. So very, very new data for you to work with. He's also providing soil electroconductivity at 2 depths that was also collected this year, so very fresh data. And then he's providing you 3 to 4, depending on which field you were assigned, years of yield monitoring data. So corn yield in 2016, soybeans yield in 2017, and then cotton in 2023 and cotton 2024. For the case of cotton 2024, this only applies for actually the 50-acre field. I don't think the beach field has it. So just one of the fields has 4 years of data, of yield data. The other field only has 3. And he also tells you that he wants the next crop he's going to be planting, in this case in 2025, is corn. All right, so that's the setup of the situation, of the case. I have some directions here for you. So I do want you to fill in your first and last name on the YAML of the script. So all the way up right here, I want you to write your first and last name. As far as data, I have uploaded all this data to GitHub already. We're going to go through that, and everything is in shapefile format. So the way that I want you to set things up for success is, since this is a completely different field than what we did in class, with different, I mean, the same data types, but different field, you should not use the same RStudio project and folders from class. I suggest you here a workflow for you to follow to make things more organized, which basically involves you creating an overall folder. So a new overall folder that you can call Final Project, your initials. Inside of this folder, you can create data, code, and output. You can download the latest GitHub repo data, which I just shared with you a moment ago. You can copy the files from the 07 Final Project, and only for a specific field. So what you're going to see from GitHub is this. I want you to copy the instructions into your folder. And when you copy the data, just copy from the field that you were assigned. Don't copy both. You don't need both. And then, so you create this folder, main folder on your computer, Final Project, let's say LMB or Bastos, whatever you want to call it, of course, with your last name. And then you create a subfolders, code, data, and output. On the code, you move this project instructions inside of there. And then on the data, you move just the data for your field inside of there. And then create an RStudio project at that level as well. Just everything that we've been doing, right? So let's just take a looking at the data that I'm providing you with. Let's say we look into the 50-acre field. If you go in there, there is a subfolder for boundary. It's a shapefile. There is a subfolder for EC. This is the shapefile for the electroconductivity using the various. You have a soil grid folder that has the gridded soil samples across this field on a 1-acre size grid. And then you have the yield, which then it has different folders for different years of yield data. And the same for the beach field as well. Now, on your workflow, you're going to be required to follow very similar steps from what we did in class. There's a few things that are going to be a little bit different. So one of them, for example, is in class, we did not do an exercise interpolating soil data, soil gridded data, right? In this case, we do have that layer. So I want you to go and interpolate the soil grid data for phosphorus, potassium, and pH only. What you're going to notice is that on that soil gridded shapefile, there are many other columns. I do not want you to work with all of them. I just want you to identify the phosphorus, potassium, and pH columns and use those. After you do that, after you do the interpolation of soil properties, then you do work on the clean yield data, you wrangle the clean yield data, or you wrangle the yield data, you clean the yield data, and then interpolate the yield data for each one of the years that you have available. And then you use that to perform a yield stability analysis for this field. So notice that for one of the fields, you're going to have 4 years of data. So your spatial temporal stability analysis will be comprised of 4 years instead of 3 like we did in class. For the other field, the beach field, we only have 3 years of data, so it's similar to what we did in class. Then from the EC layer, on that electroconductivity layer, you also have elevation data in there. I want you to use that elevation point data and create first a raster of elevation and then all the other terrain properties as well. So elevation, slope, aspect, full direction. I also want you to interpolate the soil electroconductivity layer as well for 2 different depths. We have the shallow and the deep. After that, you bring all those layers together to create zones using k-means. You're going to determine the number of zones you want to have for this field. You're going to smooth those zones and then validate them with all the terrain so you see any variables. And then create a possibly variable rate nitrogen prescription for the upcoming crop, which is corn. I want you, even though in class we did this only once, but on the final project, make sure you add the elements of scale and north arrow to every single map you make. If you forget, you're going to lose points for sure. So make sure you add your scale and north arrow to every map you make. You are welcome to use the code that we develop in class. Of course, you're going to have to adapt it, but you can start off with that code and then change things as you need to change to make it work for these 2 new fields here. One thing that I really want you to focus is, although you're welcome to use the class code as a starting point and then making edits, make sure you understand what each line of code is doing, what each chunk is doing. This is your chance of revisiting everything we did during the semester for a new field. So this is your chance to really see, did you understand every step? Was it clear to you what each step was doing? Make sure that you be aware of that. Try to understand what's going on so you can maybe identify gaps in your understanding and then understand now. You can follow up with questions to me, to Neva, to your colleagues. So this is the moment you're going to have to apply everything you learned to a new set of data and assess your blind spots and improve them as well. My suggestion to you as you work on the final project is that you have a separate Quarta script for each step, just like we did in class. What I would definitely caution against is you having one Quarta script that you do all of these steps. Don't do that. Your script's going to be so long, it's going to be so difficult to find things, and if anything goes wrong, there's just a recipe for mess. Make sure you break down your steps into different scripts, just like we did in class, and that's going to help you get through it. Also, in class, we created a whole new RStudio project for each one of the steps, right? So we did one for EO cleaning, one for terrain properties, one for EC, and so on. Here, what I propose you do is have just one RStudio project for your final project and have multiple scripts inside of this project. That way, you keep everything the same project, but still compartmentalized by script. That's going to be the best way to help you out. All right, let's talk about, well, I guess before we talk about troubleshooting, any questions until this point? Right. I don't hear anything, so let's keep moving. Troubleshooting. I am sure that you're going to run into many, many issues, many code issues, many questions. This is common, it is expected, it's part of your learning process. It's part of my learning process, making mistakes and learning from them. So what I want to tell you is this is an individual project, but I do encourage you to help each other. So maybe especially if you run into similar problems. With that, I want you to ask GitHub to ask questions because your other people are going to be working with the same data as you. So it is possible that other people are going to find the same challenges and constraints and questions as you do. So make sure to ask questions on GitHub. That way, other people can benefit as well from your question, and maybe they're having the same issue. So make sure that you do ask questions on GitHub. So do not email me your questions. I'm gonna ask you to, if you do that, I'm gonna just ask you to re-ask your question on GitHub. You can watch the repository so you get notified when somebody posts on issues. That way, you can help others and others can also help you. You can receive those notifications. And again, the goal of you using GitHub is to help each other, right? So your participation, part of your participation grade of this final project is going to be if you have used GitHub at all for help. It's okay to ask questions. It's great if you can help others when others ask questions as well. So just try to be active on GitHub as well as you navigate the final project. So this is just a list of steps I have for when you have questions. The first thing is use yourself as the resource. Try to read the error message, see if you can make sense of that message. Sometimes the error messages are really not useful. Sometimes they are. Just try to look at the error message, see if you can maybe Google that error message and see if you get help. Then using Google, you can use ChatGPT if you wish. I do not um, recommend that you use ChatGPT to develop whole things for you. I think you can use it for troubleshooting. You can give it like the code in the error and say, what's wrong here? It's going to try to help you with that. You are welcome again to work together in the sense of asking questions. If you're not sure how to do something or if you're stuck on the step, ask on GitHub for help. That's okay from my side. You can work together, you just cannot copy each other. That's what I don't want you to just copy your colleagues, because then you are missing the chance of learning or reassessing your learning and applying to a new data set. And then as a last resource, we have the teaching assistant, Niva, and myself as resources. So if all of your previous sources of help failed, then reach out to us. We'll be glad to help you. Also, you can do that on GitHub. All right, as you can see, I have a lot of instructions here, and I know it's overwhelming. I want to go through them in class just to make sure that you can see them, but you'll need to reread these instructions on your side. They are all on the script, right? You don't have to memorize. They're all here. And failing to follow each and all instructions will make you lose points. I have had so many times on this last project that I ask, for example, I ask very clearly here, add a scale and north arrow to every map. If you forget because you didn't read again the instructions, you lose points. So just don't make sure you lose points on silly things like that. That it just requires your attention and reading of the material. Read the material again, maybe 2, 3 times if you need. Come back to it later if you need. It's all going to be here. If it's on the script, it's going to be part of your grading rubric. So make sure you do it. In the end, you will turn this script to me. So this project instructions is what you turn in to me on ELC. Make sure that you do not remove any of my instructions or questions or my heading levels. Don't change the heading levels because that changes everything when I'm grading, and you don't want to do that. You don't want to make my grading harder on your assignments, so make sure you do not mess with the heading levels. When render, your questions should appear in the table of contents. That helps me to grade. Also, in this script, you should not run any analysis related code. Or let me say this differently. I do not want you to use this script to do wrangling, EDA, analysis, interpolation, any of that. That is not going to happen in this script. This script here, I want you to use to only answer the questions that are coming right below here. And so you may use code in this script to bring a figure or maybe bring a table to answer the question. But I don't want you to fully develop a ggplot figure in the script. So you develop the ggplot figure in another script, export it as a PNG, and then just bring the PNG in this script. Here, all the code you do is only to bring in a already done made figure or a ready-made table. That's it. Every time I have a question, even if you need to bring a figure or table, I still want you to provide me an interpretation of that and to fully answer the question. So if I'm asking you something and you need a figure to help your answer, bring the figure, but do not forget to write the answer down. The figure or the table do not replace a written answer. You still need to write your answer with words in the script, even if everything that the question is asking is present in the figure. But I want you to interpret that and tell me with your own words what's the answer. And here I give a few helping tips. So if you want to bring a figure into the script that you already created and you already exported to the output folder of that project that you're going to create for this final project, you would use something like this, where you just have to remove the apostrophes. It would be like this. I have the apostrophes so the code doesn't try to do it for me. But this is the syntax of embedding a figure in Quarto. When you're creating the figure, add a descriptive title and that the legends are professional and include units. So if your legend is for yield, it's a color scale for yield, you want to say yield pounds per acre or yield kilograms per hectare or whatever it is, the units, you want to include that. When you're creating figures, make sure that when you're changing color and fill, make sure they're colorblind safe and friendly. If you want to bring into this script a full data frame, so let's say that you did a summary or you want to do a summary of a data frame, you can bring the data frame into a summary, or maybe you can have already done the summary elsewhere, export it as a CSV and just import the CSV here. Then you can use like a read CSV or read Excel just to show that summary or the table here. You can do that as well. Make sure to avoid chunks that print unnecessary messages and warnings. We already went through how to avoid that behavior. Can add this warning false in the chunk. That helps with that. You do not want to have long prints. So if you bring a data frame that has 100,000 rows and you want to show me the initial rows, use head. Do not just print the whole thing because that's going to be really long print in your Quarto rendered HTML. If and when you use code chunks in this script, make sure that when you render, the chunk does not appear, just the output of the chunk. Think of this script as what you would turn into your customer who does not understand or care about programming languages and the code. So if you need a code here, and you will need to code to bring images and tables or data frames, it's okay to have that, but you do not want to show the code in the final render Quarto script. And lastly, make sure that you render and check how it looks. If it looks weird, if it does not look professional, if you look at the output and it does not make you proud of seeing that, you need to change it. You need to make it professional looking. Imagine that this is the report you're turning into your customer who's paying you for a job. You want this to be of highly professional, high professional quality of your final product. Okay, before I keep going, I know I'm just saying a lot of words here, so I just want to leave a moment to check if anyone has any questions. All right. I don't hear any questions, so I'm going to keep moving here through the explanation of the final project. Grading. How am I going to grade you on this? So the first thing is you have some opportunities for extra credit. If you answer them correctly or if you do them correctly, that grade that you got for the corrected extra credit will replace the grade of another answer that you may have missed. So you don't have to do the extra credits as extra credit parts of the questions or questions, but if you do and you get it right, it replaces another question that you may have missed points on. So in general, you're going to be graded on the following. First, correctly answering the questions. Make sure you answer all parts of a question for full credit. Some of them have 2, 3 sub-questions inside of one. Make sure you answer all of them. Following all the directions. So just a quick example here. If you forget to add your first and last name at the heading of this YAML of this file, that is such a small, simple thing. But if you don't do it, you lose points. So if it is a direction that I wrote on this script, you want to follow. If you don't follow, it's an easy point that you lost that you could have avoided losing if you just follow that. So again, make sure you follow all directions that I write on this script here. You have to use proper grammar. That's going to be evaluated. You will be also judged on the professionalism of your render file. So remember, I don't want to see code. I do not want to see long warnings and messages. I do not want to see long prints. Make it professional looking. You're going to be graded also on the use of GitHub, both to ask questions and to help others answering and helping others with their questions. And of course, by turning in on time. You need to turn this in on time. All right. So this is all the setup, as you saw, pretty long, but I wanted to take time to go through it with you so you understand what I'm expecting of you. Now I basically have questions. I'm not gonna go through each one of the questions. There are 22 questions and 2 other extra credits. So there's a lot of questions that, again, so for example here, question number 1, show a map of interpolated soil graded variables of phosphorus, potassium, and pH. So you need to bring in the maps here. Provide an interpretation. On your color legend, use the color breaks according to sufficiency levels for corn. In this case, would be for phosphorus and potassium. So you need to know what are the sufficiency levels for corn of phosphorus and potassium. You need to make maps of the interpolated. You need to first interpolate the variables and then do maps. Add a north arrow and a scale. Use a color legend that makes sense that we already talked about, colorblind friendly, and bring those figures here by using that exclamation point, brackets, and then given the path to the figure that will embed the figure in the script. And finally, of course, you have to provide your explanation. So the questions here basically walk you through the entire process that you did throughout the semester. So we're going to have interpolating soil properties, looking to your raw yield data, defining a negative buffer, number of observations, and a statistical summary of your clean yield data for each one of the years. You're going to have to tell why you chose a given grid cell size. You're going to show a map of the interpolated yield data for each year. There's a lot of things here that is going to walk you through what I want you to do. And again, if there is any question specific to one of these questions, let me know. I'll be glad to clarify if it's confusing. But basically, going to be asking these questions here by, again, creating what I'm asking, like a map or a table, elsewhere in the script of that part of the exercise. On that other script, you do the analysis, the wrangling, the EDA, everything you do there, export the figure, and then here you just bring in the figure or the table to answer the question. That's all I need on this script. You're still developing all the other scripts all the other analysis figures tables in their own scripts. Here, I just want you to give me the answer and the figures and tables if needed. Yeah, so we have 24 questions for you to answer all in the script. All I need from you at the end is just the render version of this script. You do not have to send me all the scripts you used to create the analysis, the figures, the EDA, the tables, all that I do not need. All I need is this script to render. That's all you have to send me or have to upload to EOC. And the deadline is April 29th, 11:59 p.m. I have some code tips for you here. It's just everything. I think everything here is already things that we've done in class. So you know already. I'm not going to cover them one by one. I have a tip for troubleshooting a pipe stream. So if you have a pipe stream that's not working, you just block the pipe, run until that point. If there happens, then you know it's there. If it doesn't happen, there's no error there. You'll let this pipe go through the next line, block the next pipe, run until next line, check if it's there, and so on until you find where the issue is. You're going to have to use k-means to create the number of management zones. And I propose that you use the techniques of the within sum of squares and the silhouette width, and do not use the nbclus function, which was that function that provides us with like 24 indices. I'm saying that because I tried that on my computer and my RStudio just took a long time and crashed. So for you to, I would say for you to avoid using the nbclus function, just use those other two that we have in the code as well, the WSS and silhouette width, to determine your number of clusters. And then throughout your not on this script, but on your other scripts, you may need to export spatial data. Remember to use write_sf and to include delete dsn equals true when you have to do that. So you don't append, but overwrite in case you run this piece of code more than once. All right, so this is your final project. This is your chance of working with real, I mean, we already were working with real world data. The difference is that the grower that we were working with, or the data that we were working with during the semester, I do not know that grower. I do not have a working relationship with that grower. I do, however, know and have a working relationship with the grower of the final project. So in the end, I will send your reports to that grower and let them look at it and make sense of it. With my goal is that you, through the final project, you solidify your understanding of everything we did during the semester. In the process, you're creating recommendations, you're creating analytical workflows that are applicable to hands-on precision ag on the data side of things. And then I will provide your reports to that grower. So maybe he or she's going to look into it and be able to tell, what is going on with his data, what is going on with his field, because he has all this data, but they never really looked into it to the depth that you're going to do in class. So I think it's really cool, really interesting, because you have a chance of helping a grower, a real grower here in Georgia, with their data by doing this assignment. So in the end, I will share your reports with the grower, and perhaps they learn something new about their field, perhaps they change a management practice based on your answers, which I think is really exciting. All right, so that is the introduction of the final project. That's all I had to share with you at this point. Anyone has any questions about it? All right, no questions. So just to tell you the roadmap from today onwards. So you have about 2 weeks to finish this final project. Make sure you get started on it sooner rather than later. As you saw, there's a lot of moving parts. You will for sure have problems with code. Everyone does. I did when I was making it. So do not leave this to the last moment, because if you're gonna depend on others to help you, you want to give them and you time. So make sure you start, do not leave this to the last 3 days. You will not be able to turn in with everything complete if you just give yourself 3 days. Use the time I'm giving you. You have 2 weeks. Use this time to fully develop your project, and you should be good. All right, so I think I was still going to tell you the roadmap. So today I wanted to focus on the final project. If nobody has any questions, I'm going to stop the recording and I'm going to give you the next hour to work on the final project. I'm going to be connected. If you have questions, I can help you. So you get a head start on your final project. Before I stop the recording, I just wanted to say as well that on Thursday, we're going to do one more exercise on the satellite imagery. So we did pull data, the mean of the growing season, and also the daily data for 1 year of the data we're working with in class. Next class, we're going to pull data for 2 other years and do a spatial temporal, not yield, but green NDVI analysis. And we're going to check how well that compares to the results we got when we did that analysis with yield data. That's going to be the next class. And the next week on Tuesday, Neva is going to present an exercise using hyperspectral drone imagery in Precision Ag. I'm really excited. You're going to get a lecture from Neva and also a lab on that topic. So that's the roadmap for the next week. I guess before I stop recording, anyone has any questions about any of that? All right, so let me stop recording here.